Hey, welcome to the Brain Gauge channel, and I'm going to talk about temporal order judgment in this video. And this is how you get the TOJ and connectivity scores. Now, very briefly, if you watched one of the last videos, we talked about illusions and that you can generate illusory conditions. And the reason illusions work is because the brain connects the dots. And that's really all we need to say about that. And just keep that in mind. Now, what is temporal order judgment? That's basically which stimulus came first. And that's how you get a baseline measure. And as we discussed before, we use tracking, which is just like reading an eye chart. And that's what you see here. Now, when you do the temporal order judgment measure, you get a score. It's usually normal is in the 20 to 30 millisecond range. And if there's something wrong, mostly in the frontal striatal area, basically that score gets a little bit high. Mentioned in another video, the extreme cases in TOJ is like schizophrenics are very, very poor at understanding order and don't do very well at that. Get knocked in the head pretty hard. Sometimes you don't do well at that. Subjects with autism do a little worse. Adolescents with ADHD don't do very well. But what I'm showing here are the different scores in the bottom for some of the what we call the baseline TOJ scores. What's kind of more interesting is if you actually deliver an illusory conditioning stimulus. Okay, so take a look here, and what we do is we give a little bitty illusory conditioning stimulus, and that's just a little bitty vibration on your fingertips, and it basically all it does is makes your fingers feel like they're the same, and that you deliver the exact same stimulus to those fingers, and then we do the TOJ test, and then look what happens. All those scores get worse in the normal condition. Now, in things like autism and concussion, they don't get worse. And that's kind of interesting. Focal dystonia gets a lot worse. Focal dystonia, or these are musician's cramp or writer's cramp. Basically, that's where these two fingers are functionally hyper-connected. But if you have dissociative connecting, or basically abnormal functional connectivity, then you get a disparity in that number. And this is what we call TOJC, or TOJ carrier, because there's a carrier frequency that we deliver to get to deliver the illusory conditioning. So basically, the basic hypothesis of this is that when you deliver one stimulus to one finger, and look at this, D2 stands for digit 2, deliver a stimulus to digit 2, and what happens is, let's see, here is the digits 2 stimulus, and here's the response in the brain. And notice here, there's not a whole lot of response. Well, that's because that's the digit 3 response. And so, you simulate digit 2 and you don't get much of a response. And then in digit 3, but you do get response at the digit 2 representation and then the cortex. But if you do another stimulus, but in this time with that carrier frequency attached, look what happens. Now, digit 3 has activation. So what happened was this activity, this little bitty carrier frequency, made the activity in digit 2 transfer over to digit 3. There was crosstalk between the two digits. In other words, the two digits start working together. And so when you deliver that carrier frequency, you deliver a exact same stimulus to both fingers. What it does is it makes those fingers feel like one. And also when you deliver one stimulus to one, they both respond. That makes it very, very hard, very difficult to tell the difference. Okay, so that's a really interesting thing, and but that functional connectivity can get disrupted very easily. So we did a bunch of studies because when we were writing papers, people said, oh yeah, this couldn't be anything. So we would do things like do it on different hands and do it on different, look at one hand or the other. But the bottom line of this slide is that the stimuli have to be, in order for this to work, the stimuli have to be periodic and sinusoidal. Any other combination does not work. That's what this slide means, is that you will not get this. So you have all these different combinations of stimuli. It's not just a noisy stimulus that makes you confused. It's actually that you've locked this stuff in, and it is synchronized, in which the last slide showed that pretty well. Now we also did a validation study with this where we applied TMS, where we did the same study. We saw that TOJ was in the normative range, and then the TOJ synchronizer carrier was 3 times the normal. And then when we applied TMS to somatosensory cortex, basically TOJ was now normal and went back to actually outperformed what it did before. So we blocked the synchronization and the synchronization effect, and actually TOJ was much better. If you want to read about this, there's a lot of papers on it, and they go back to 2007. And that's all.